Bienvenidos, Sushamdid, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's ITNv7 course curriculum, or the Introduction to Networks course, the first of the three new Networking Academy CCNA courses. And in this packet tracer activity and tutorial, we're going to be taking a look at packet tracer 12.9.1, where we're now going to be digging in to IPv6 and implementing an IPv6 subnetted scenario. So we're going to be talking about the global routing prefix, the interface ID, the subnet ID, and we're going to add some value around this conversation in terms of how we're doing things here and how you can easily and quickly identify the addresses that you're working with. So as you can see, we've got a background scenario. And so we're just basically going to be completing this subnetting chart. You can see we've got our link local addresses over here. Again, remember, link local addresses are considered unicast addresses, right? It's a unicast address. It's just referred to as being link local because it is only significant on that local link. So let's go ahead and scroll down here. You've been asked to set up the network for use by the sales staff for a customer demo. Now the network's going to use a series of consecutive IPv6 subnets for the 4 LANs. Your job is to assign the subnets to the LANs and configure the routers. All right, so step 1, determine the IPv6 subnet and addressing scheme. Well, there is our /64, and this is going to be the IPv6 subnet that we've been provided. Now, remember, the first 48 bits, in other words, the first 3 hextets, I'm in IPv4 mode. The first 3 hextets, each hextet being 4 hexadecimal characters. Remember, these are not decimal characters, because A, B, C, D, E, and F, those are not decimal characters, right? Those are hexadecimal characters. So each set of 4 hexadecimal characters is a hextet, and it is also 16 bits in all. Even when, if you see the colon here, there are a series of zeros, right, of 4 zeros multiple times. In this case here, there are a series of 4 zeros in there, so there are 16 bits. Even when you see 3 hexadecimal characters, remember, these are not being written out in what we read about in Chapter 12, which is the preferred IPv6 format to write an address out. Now, I'm not sure why it's called the preferred format, because it is certainly not preferred by me when I'm writing IPv6 addresses out. And all the preferred format is you actually put every single hexadecimal character in the IPv6 address, whether it is a 0 or not. Now, I much prefer what I like to refer to as the consolidated format. And so this second hextet here, the leading 0 has been left off because, again, that's one of the rules, something that we can do. And the same is true here. Between the colon, there are a series, if we have 128 bits total in our IPv6 address, and 64 of those bits are indicated here, the colon is actually compressing or consolidating 4 hextets, each with 4 zeros, right? And so this is how we can abbreviate, right? And you'll also hear it referred to as the abbreviated format. So now let's go ahead and figure out what we're going to do here. Now, they've given us the first subnet, which is this 2001 DB8 ACAD. And so we can say that the first 48 bits, that is considered to be the global routing prefix, right? So these first 48 bits are the global routing prefix. Now, these 16 bits that sit in here, this is referred to as the subnet ID. Now, remember, I explained when we were talking about IPv4 that the idea or the concept of subnetting based on classful boundaries, right? That no longer exists. So we're not talking about a Class A global unicast address or a Class B. There are no more classes. And in fact, the subnet ID, these 16 bits, and you could say from bit 49 all the way to 64, right? All of these bits in here, this hextet, this fourth hextet, that is the subnet ID. And what that means is we can go ahead and manipulate. And if you think about it, 2 to the 16 is 65,536, right? That's a lot of subnets. So with IPv6, if we're dealing, and we've been given a /64 here, if we wanted to, if we were given the /48, right? And that's typically what will end up happening is you'll be given a /48, and then these 16 bits in here you can use to create multiple IPv6 subnets. In fact, 65,000. With a single /48, you can create 65,000 subnets. I'm not sure of how many companies out there that need 65,000 subnets, so 1 /48 is probably going to be sufficient if you manage it properly. Now, again, we don't see the last 64 bits that is in this : here, which, again, it's going to be 4 sets of quad zeros because there's nothing in there, right? So what do we refer to that? Well, those last 64 bits are referred to as the interface ID. So again, Global Routing Prefix, the first 48 bits, Subnet ID, the next 16 bits, interface ID, the last 64 bits. And I didn't want to grab the slash there. The last 64 bits. So again, with 64 bits, right, we would say 2 to the 64, we end up with right around, and I shouldn't say right around, it's 18 quintillion. In fact, let's pull the calculator out, see what the calculator says here. So if I was to say 2 to the 64, we're probably going to get some ridiculous, yeah, and it breaks it out into scientific notation here. So, but you can see 1.8, so it is 18 quintillion. That's how many IP addresses we get if we have 64 bits in the interface ID. And again, right, there's no way that you as an enterprise are going to use 18 quintillion addresses in a single /64. It is not going to happen. That is a lot of addresses. So let's dive in here, and I'm going to draw some analogies, right, when we go to do creating the subnet. So we're going to use the subnet ID field here, and this is the field that, let's call this our interesting hextet, right? Like when we were doing subnetting with IPv4, I would say the interesting octet, right? Here it's the interesting hextet, which happens to be that subnet ID, these 16 bits that we can manipulate to create multiple /64s. All right, now the key here is subnet the addresses consecutively to by 1 to arrive at the 4 required subnets. All right, well, they kind of kick things off here so that this is going to be sort of easy, right? So if I look at, because again, we're interested in those 16 bits. That's where we're doing our subnetting, and that's going to be the important field. So if we look at our address, there is the global routing prefix, right? So if we're going to increment by 1, and we're going to go from right to left when we're doing this incrementing, it would be 0, 0, Charlie 9, right? Because we're incrementing by 1. So again, this is sort of going to be easy from this perspective. So here's what I'll do. I'm going to draw in, at least for the first one, it's going to be easy, I should say. So let me get the drawing tool out here. And so we're going to say that everything is the same, and then we're going to have : 0, 0, Charlie 9, right? And then it's going to be : /64, because all I'm doing is creating new /64s. And so this one has 18 quintillion addresses available. I'll just say QI. 18 quintillion. This one has 18 quintillion, right? So these subnets should meet even the most aggressive addressing scheme in an enterprise network. Now, here's the challenge. Let's go ahead and let's break this out. And so we could have also written this as 2001 DB8 ACAD colon. I could have written it as well as colon Charlie 9 colon. If I wanted to, I could omit these leading zeros. And so I'm going to do that the rest of the way. Remember, that's one of the IPv6 rules, that if you don't like the preferred format and having to write out, all 128 bits, right, which is going to end up being 32 hexadecimal characters, if that's not what you're into, then you're going to want to use the abbreviated format. And we'll do that as we go forward here. But first, let's take a look at this, right? Let's break down that 0, 0, Charlie, and we'll start with the 8, right? Because I said we're going to go up by 1. So these are hexadecimal characters. Remember that. It just happens to be that they're in the Subnet ID area, but they're hexadecimal nonetheless. So 0 in hex is what in binary? Yeah, it's going to be 4 bits. It's a nibble. And if it's 0, and let me make this an arrow so it doesn't look like a 1. A 0 is just simply quad zeros. And the same thing here. 0 in hexadecimal in binary is quad zeros. And that's why we can leave these out at the beginning of the address. So here we have C. Well, remember, C in hexadecimal is equivalent to what decimal value? Well, A is 10, B is 11, C is 12. So 12 in binary is 8, 4, and then 0 for the 2 and 0 for the 1. That is 12. Remember, we're looking at each of these hexadecimal characters as their own individual, mutually exclusive value that we can convert into binary, into 4 bits, into a nibble. And then 4 plus 4 plus 4 plus 4 is going to be 16. That's where we get that hextet. And again, the hextet is more of an unofficial designator for IPv6, but believe me, it is used abundantly when discussing IPv6. All right, then we get to the number 8. Well, this is going to be an easy one, right? So 8 in hex is going to be 8, no 4, no 2, and no 1. Remember, think of it in the IPv4 sense, think of it as we're dealing with each of these as their own little low order 4-bit values, where the first value is 1, and then 2, and then 4, and then 8. We just need to make sure that we remember that these are individual values so that it doesn't go 16, and then 32, and then 64, and then 128, and then 256, 512, 1024, 2048, so forth and so on, right? Each of these hexadecimal characters is represented by their own little low-order 4-bit values that we can then convert from hex into decimal into binary, right? And that's all we're doing here. Converting from hex, we figure out what the decimal value is based on the hexadecimal character. C, we had to stop and think about, but 8, okay, 8 in hex is 8 in decimal, and then I convert it into binary. So when it says increase by 1, right, the 8 becomes a 9. And so that 9 would be 8, 0 in binary, 0, 1. And that would equal 9. Now to go up again, remember, that's what it's asking for. Make sure to configure, oops, sorry, not that. Let me pull that out. Where's the consecutive? Here it is. use a series of consecutive IPv6 subnets for your 4 LANs. So after 9, what's next? And this is why they've got this activity set up the way they do, because they're hoping that you're going to walk right into this. Oh yeah, it's 10. So I want to do 10. Well, remember, in hexadecimal, it goes 8, 9, A, B, C. There is no 10 hexadecimal character, right? There is no hex character that is that. All right. So let me pull these out, pull that out. So we know that the next, going up by 1 from 9 to 10, it's A. It would be A. A in hex has the equivalent value, right? Went from 8 to 9, 9 to what would be 10, but represented as the A in hexadecimal. So 10 in binary is 8, not the 4, the 2, and not the 1. So now we have 1, 2, 3 subnets. Next is going to be B. And what is B equivalent to in decimal? Well, in decimal, B is 11. In binary, it would be 1, 0, because that would be 12 if the 4 was on, and then these last 2. And then we have our 4th and final subnet that we're going to create, and that's C. Well, if A is 10, B is 11, and C is what? 12. So 8 and 4, and then 2 and 1 are off. And I'm going to leave all of this up here while we do our configuration. And so now, what is our subnet ID hextet going to look like after 00 Charlie 9? Well, it's going to be Charlie Alpha. And then you would put colon, right? Because the subnet ID field is taken care of, /64, meaning the first 64 bits. And here's another analogy that you can think of. The first 64 bits represent the quote unquote network portion of the address. So that's slash notation, even though that's referred to as the prefix length and not the subnet mask length, right? We refer to this as the prefix length. We can think of it just like we do in IPv4 when we say that the first 64 bits, right, the 48 global routing prefix bits and the 16 subnet ID bits, those 64 bits represent the network portion of the address. And in fact, they really do, right? Because the last 64 bits are my interface ID. And again, we end up with 18 quintillion, I'll just put a Q here, 18 quintillion usable addresses in that address space, right? It's kind of crazy when you think about it. So then what is our third subnet we've created, right? This was given to us. So I'm saying here's number 1 we created, right? 2 overall. Here's the second one we created, 3 overall. Third one we created, 4th overall. And the 4th one we're going to create, which is our 5th overall. So it would be Charlie Baker. And you notice the leading zeros I'm leaving off here, /64. And then finally, we'd have Charlie Delta. I'm sorry, Charlie. Whoops. Knowing your ABCs is very important when working with IPv6. Charlie, /64. All right. So now that we've got that sorted out, we are ready to rock and roll on the configuration. So you can see here it says complete the addressing table above to use as a guide. And we've got our addressing table here. We could scroll back up here and take a look. And you can see they're using .1. There you go. That IPv4 seeping into my conversation here. :1 as the first address, right? Is what they're doing here. And let's see what it is they're going to tell us what to do. So assign the first IP address in the subnet to the router LAN interfaces. And so if that's going to be Charlie 8, this is going to be Charlie 9, this is going to be, this is going to be Charlie Alpha, and that's going to be Charlie Baker. And it looks like, oh, okay, right, for the link between R1 and R2. We're going to use Charlie. All right, so let's dive in here. Let's jump on router 1, and let's go ahead and make sure that we're in global config mode. And I'm going to go ahead and say, do show IP interface brief. Let's see if they've got it configured. do show IPv6 interface brief, and let's see if anything's configured. So none of the interfaces are configured, and everything is down right now. So let's start out interface gigabit Ethernet 00, and we'll say no shut. And this is going to tell me which interface goes out to PC1. And good, it's going to be that top interface. So we say no shut. We're not going to need a description, and it's asking for the first IP in the subnet to be assigned to the router LAN interfaces. Well, we're on this first subnet right here, and we're going to find out, and you can see we brought the interface up, and it gave us the 2% there. So let's go ahead and say IPv6 address 2001:DB8: ACAD, and that is, again, there's your global routing prefix, right? Now I'm into the subnet field. Well, conveniently, 00 Charlie 8, and I'll use the full, we'll say for that hextet, the preferred format for that hextet would be 00 Charlie 8. We're going to use the abbreviated format here shortly. So I'm going to say ::1/64. And let's see if we get some points for that. We do, right? Because remember, we've got the : which is going to have 48 bits in it now, right? Because this last hextet here, so, and let me explain this. I need to make sure I'm clear here, right? So remember, over here I was saying, oh yeah, the last 64 bits, those are the interface ID. Well, remember, this now represents 48 interface ID bits, 48 bits that are part of the interface ID, the last hextet, which if written in the preferred format would be 0001. So there's your other 16 bits that make up the 64 bits, 48 plus 16, make up those 64 bits in the interface ID, right? So remember, what this is kind of abbreviating, the : here is abbreviating 0000:0000:, :0000:00, and then what we're seeing is the abbreviated last hextet as 0001. And that's really what this side, you know, from after we have 8 : here's what we actually have in preferred format. But I think you'll agree the abbreviated format is where we want to be. And so now I have a feeling I wrote too much here, and we're not going to be able to get all of that off. And so what I'm going to do is, this is where I bring out my trusty eraser, right? When I go a little bit too far, I think you can only go back maybe 10, possibly 12 keystrokes, or, you know, things that you've written there with the tool. All right, so let me erase all of this here. Let's get this out of here so that we're good to go. So again, hopefully that makes sense. And it's all about just working with the values over and over and over again. And the more you work with anything, right, the iterative process, the better you're going to become when you're subnetting with IPv6. All right, so we've got that address in there. Now remember, if I was to say, do show IPv6 interface brief, what do you notice was auto-magically dumped onto the interface setting? The link local unicast address. Now, that is not what I want to have to remember if I'm trying to run a ping command. So let's go ahead and say IPv6 address FE80::1 link local. And you'll see we got a few more points for that. So we're going to want to make sure we do that. Assign the link local addresses as they are in the routing table. We just did that. And so now let's go ahead and let's finish up here on router 1. Let's step over to interface gigabit Ethernet 01, and we'll say no shut. There's our second subnet, right? And you can see here they're telling us R1 gig 01 LAN. And now here's where we're going to find out if we incremented correctly, because we're going to assign, and oh, sorry, we already said no shut. We're going to assign the IPv6 address, and let's do the link local first. FE80::1 link local, and so there's our link local address, and then IPv6 address 2001:DB8:ACAD. So there is our 48 bits that make up our global routing prefix. Now we're into the subnet ID field. And let's do this. We use the preferred format just in that hextet on our first example. Now let's use the abbreviated format. Excuse me, I'm sorry, Charlie 9. Of Charlie 9. And again, first IP address in the subnet gets assigned to the router LAN interfaces, /64. And there it is. And we bumped up our points. And so now if I say do show IPv6 interface brief, you can see that both gig 00 and gig 01 are properly configured. Now on to the connection between the routers. And that's going to be this. And actually, I'm sorry, we'll do that last. We'll pull router 2 up here. And let's go ahead and get onto router 2 and get into global config and say interface gigabit Ethernet 00. We'll say no shut, right? And we'll bring that interface up. And I could check, pop in here and see, yep, spanning tree's doing its thing. If you don't want to wait here, and again, it's going to take us a while to get this done, you can always hit the arrow here, this double arrows right down here, and fast forward, and spanning tree will go into the forwarding state, and you can then move on with your activity. So for router 2, right, the router 2 gig 00 LAN, we said it's going to be IPv6 address FE80::1 link low. Oh, sorry. We want ::2. Hopefully we don't get punished for that. Okay, good. All right, so now we're going to say IPv6 address, and this is going to be coming off of the Charlie Alpha subnet. So IPv6 address 2001:DB8:ACAD. There's my global routing prefix. I'm now into the interface ID, where I can simply say Charlie Alpha ::1/64. Because again, it's the first IP that's going on the router interface. Now, I only have 17 quintillion, 17 plus quintillion addresses, 9999999, whatever, addresses left, right? So it's kind of ridiculous how many addresses you get with a /64. And we got points, so we know our subnetting, when we incremented by 1, that we were doing it properly. And I already said no shut, so let's get an interface gig 01. We'll say no shut and bring it up. Again, we could always confirm, take a look here, maybe hit the fast forward if we don't want to wait. And then we're back on router 2 IPv6. IPv6 address FE80::2 link local. Oh, too many colons. Sorry, I was going to say I thought I had link local in there, but I had an extra set of colons. All right, so IPv6 address FE80::2 link local, then IPv6 address 2001:DB8:ACAD, first 48 bits, your global routing prefix. I'm now into the 16 bits that are the subnet ID. This is going to be Charlie Baker ::1/64. We hit enter. You can see we're still racking the points up here. And that's the R2 gig 01 link. And now we get to the connection between the routers. And that's going to be this subnet down here. Now, assign the second address in the subnet to R2, the first address to R1. And again, this is going to be pretty simple. So we'll do R2 since we're on R2, interface serial 000. And I'll say no shut. In fact, let me make sure that is, serial 000 on router 2. So we say no shut. IPv6 address FE80::2 link local. IPv6 address 2001:DB8:ACAD. And those first 48 bits, the first 3 hextets, are my global routing prefix. I'm now into the 4th hextet. These 16 bits make up my subnet ID, and I'm going to just go Charlie, router 2 gets the second IP address, and we should get some points. In fact, we got 10 percentage points there for that. So now I'm going to save my config here on the router. Let's now come back out to router 1, interface serial 000, no shut, and now we've got that serial interface up between router 1 and router 2. IPv6 address FE80::1 link local, and we picked up some points for that. IPv6 address 2001:DB8:ACAD. Again, the first 48 bits, and there's a reason I keep saying this, right? Is so that hopefully you're going to be like, yeah, I know it's the global routing prefix, the first 48 bits, the first 3 hextets. Stop saying it. That's what I want, is for you to know that that is your global routing prefix. Those first 48 bits, the first 3 hextets. Now I'm into the subnet ID, the 4th hextet, these 16 bits. And we know it's going to be Charlie, Charlie, : 1/64. And we should go to 86%. I would think, well, okay, 85, good enough. And that takes care of that. In fact, let's go ahead. Let's save our config. Can I ping FE80? Well, let's do this. Can I ping 2001 DB8 ACAD : Charlie, Charlie, : 2? And look at that. We've got connectivity over the serial link. So now we're going to come down and we're going to do the final portion of this activity. And this is another reason that when you're using the IPv6 prefix length setting, right, is that you use /64s. There's a reason /64 is what you want to be using on your router interfaces, especially the LAN-facing router interfaces. On the serial link here, not so much, right? You don't need a /64 in here. I mean, because did we just not waste 99998 quintillion addresses? We did, right? But we still have 65,000 plus subnets available to us. So you might want to be a little more judicious. I mean, you could do some variable length masking here, and maybe a /127 might be something to consider in here, or something more appropriate, right? But again, it's not the end of the world that we wasted 17 quintillion addresses. We have many, many more addresses we can use. So back out to the PCs. The /64 is important, right? On the router LAN facing interfaces where we want addresses to be auto-magically learned. That's why you use a /64, is because stateless address auto-configuration, right? The SLAAC, SLAAC, stateless address auto-configuration, uses /64s. So why not use a /64? Again, you've got a gajillion, that's a new number I just invented. You've got a gajillion addresses available to you. So stick with the /64 on LAN segments where you want the IPv6 address to be auto-magically learned via SLAAC. So let's come in and see what that looks like. We come into our IP config. You can see here it says static. It's already done the EUI64 process. I'm going to lightboard this evening and then publish that video. But we just come over here to auto magic, right? But it's not working. And let me ask you, why do you think it's not working? And this was a very critical step in the activity that I intentionally kind of breezed by. Because we've got all this IPv6 set up, right? And remember, I've been telling you that you don't have to enable IPv6 unicast routing to configure IPv6 addresses on router interfaces. And you certainly don't. However, we need the router advertisements and the router solicitations. Because when I click automatic here on the PC, you're going to see a router solicitation message saying, hey, I'm trying to discover my default gateway. And if I'm looking for stateless auto address configuration, SLAAC, to get my IPv6 address, that router has to be running IPv6 routing, unicast routing, right? So we'll turn that on router 1. We'll turn it on router 2. And Control-Shift-6. Get into global config, IPv6 unicast routing. So now when PC1 gets set up and I say, hey, you're doing SLAAC, take a look at that. Boom. And look specifically here, and in fact, it's kind of tough to see in there, right? So here's what we're at 92%. So here's what I'm going to do. Let's go to our desktop command prompt and say ipconfig/all. And let's stretch this out, give ourselves a little bit more room with which to work, because this is a pretty neat conversation to have. Here is my first 48 bits, the first 3 octets, which is the global routing prefix. And then we have the abbreviated form of the prefix ID hextet, right there, the 4th hextet. Now, take a look at what happened here with Stateless Address Autoconfig. It also, again, uses the EUI64 format. And the reason I know that is right here. The FFFE gets put into the middle of what would be the MAC address. Here's the MAC address, right? Take a look at this. And do you not see that right here in the middle, we get FF:FE placed into the middle of that 48-bit MAC address to give me a 64-bit globally unique interface ID address. That's what's happening here. Because look, you don't see the leading 0 here, right? And again, I'll talk about this too, because we got some fancy stuff going on here where there's a bit that's going to be flipped. But we don't see the leading 0, and then this 0 gets converted into a 2, right? We don't see that. But what do? See? You see the 30, there's the Fox 2, and then we insert FFFE, and then Baker Alpha 2 Charlie 3 Alpha. That's how it's done. And because the MAC address is globally unique, it guarantees that the IPv6 stateless address autoconfig, right? Think of it as this is how the IPv6 address is auto-magically generated on this PC. It will also be globally unique. Now, can you get on there and hack it and change the MAC address so that it matches some other MAC address? You certainly could. However, for our conversation, this is what we are interested in. And that is exactly how it's happening. There's the default gateway, right? When the PC was told, hey, you're going to be using stateless address autoconfig, you're going to get your address auto-magically, it sends a router solicitation out. You'll notice we didn't set the default gateway, did we? There is no setting on router 1 where I said, oh yeah, for DHCP, use FE80::1. No. It happens auto-magically. So you can see a lot of the enhancements with IPv6 and a lot of the advantages of IPv6 over IPv4. So there's our information. So let's finish this activity up, right? Let's come on to PC2. Excuse me, we'll pull it down here out of the way. And we'll go to here, and then we'll simply click, and it's this easy. Boom. It's a /64. You can see it's grayed out there, but that's what's important. We get a router solicitation, router advertisements are flying around, and here's my information, right? There's my MAC address with FFFE put in the middle. PC3, right? And you can see the last part of this activity is pretty easy. And then PC4, auto-magic. The tough part here is remembering that yes, you can configure IPv6 addresses on router interfaces without having to enable IPv6 unicast routing. However, in order to get it to work correctly, if we're talking about SLAAC and stateless address autoconfig doing any kind of routing with IPv6, we want to enable IPv6 unicast routing. And this should also answer an interesting question, which I've posed before, which gets posed to me all the time. Why doesn't Cisco have IPv6 unicast routing on by default on the routers? Well, here's your answer. Why would you turn that on and have router advertisements being sent, right, off router interfaces with IPv6 addresses if you're not doing IPv6 routing or you're not doing SLAAC? You wouldn't want that. Again, Cisco configures it for IPv4. That's enabled by default, right? But if you're going to do IPv6, it needs to be an intentional thing, right? They don't want to have it set up so that it's doing something, right? Sending router advertisements as soon as you possibly configure a link local address or something like that, when that's not what you're going to be doing, right? They want it to be something that you do intentionally. All right, well, that is going to wrap up this packet tracer activity 12.9.1 on implementing IPv6 addressing. Again, definitely one of the more challenging activities to date. If you have any questions, let me know. If not, thanks for watching, and I hope to see you guys in the next video.